Hello everyone, welcome back to the channel. In this video, we will learn about React agents and we'll build a React agent using LangGraph from scratch. Okay. Before starting the video, I'll just talk about this playlist here. So before this video, we have already discussed a couple of topics in LangGraph. First one was an introduction to LangGraph and what is graph, and how do we create nodes, edges, all these things we discussed in the first video. In the next video, we discussed about state graphs and the concept of state in LangGraph, and we also saw a sample workflow in which we saw how the state flows across various nodes in LangGraph, in a LangGraph workflow. Okay. So now in the next video, in this video, we'll be talking about uh, React agent. What is React agent? How do we use a React agent? Why do we use a React agent? And how can we create a React agent in LangGraph from scratch? So we'll see all of these things. So first of all, we will see the conceptual or theoretical part of React agents, and then we'll see the coding part of it, where we will code this React agent using LangGraph. So we'll create a workflow for this particular React agent. Okay. So to start off with, the first question is, uh, what is React? First of all, so React is nothing but reasoning. React stands for reasoning and acting, right? So now, what is reasoning? So reasoning is nothing but thinking step by step about how to solve a problem. Okay. So whenever we have a problem, or whenever this agent gets a query, so it starts off with reasoning. That is, it starts off with thinking step by step about how to solve the problem. And then the second step is acting or action. So once it decides on the approach, how to solve the problem, then it goes on to acting or taking actions. So in acting part, we use tools, right? So using tools or performing actions to get results. So either it can be a tool or it can be LLM call. So using which we'll get the results. Okay. So this is the basic concept of React. So React is nothing but reasoning plus acting, right? Reasoning is thinking step by step about how to solve a problem, and acting is using tools, functions, LLM calls, whatever it can be, to perform the actual actions. Okay. So this React is not only about answering questions or responding to the queries, but it also can take actions, right, using some tools. So now, what is the goal? So goal for us is to build an AI that thinks. This is really interesting. The AI that thinks. First of all, it will think, and then it takes action. It not only thinks and responses, but it also take an action. Okay. And then it thinks again based on what happened. And this goes in a loop until we get the satisfactory answer. This step, this step goes in a loop until what? Until we get a satisfactory answer or response. And this is React. Okay. So now we'll see why React. Why shall we use React? What is the strength of React? So in most of the AI systems, either we have just an LLM which answers our queries, right? We give a query to the LLM and we get the responses. Or we might be having some scripts or some functions to take some actions or to do some activities, right? But React provides a mix of both, both thinking and acting. So now we'll see. So React basically combines both of these concepts, right? So first of all, it reasons that what should I do? What should I do? Right? So this is the thinking part. And then it acts. So it can use some tools. Let's say it can use a tool to search online, right? It can use some custom tool to do specific activities, right? So first it reasons, it thinks, and then it acts. Acts using some tools. And then in the third step, it reflects, it observes, right? Now that it has the answer, so what is the next step? Is the answer correct, right? If not, then it again goes back to the loop. So this thing goes in a loop. So now we will see how exactly this React agent works using an example. Okay, and then we'll also see some screenshots which I've kept here. So first of all, we'll see how do these React agents actually work. Okay, so so particularly this React agent goes in a loop as we discussed above, right? So let's see an example. So the first step is thinking or reasoning. So it asks there basically what is the best way to solve this particular query or issue or problem statement. And the second step is acting. So in acting, it can use a tool as we discussed. It can use a tool like a calculator, right? Use an API, run a tool, a custom tool, right? To act on that particular query. And then it observes. So in the observation, it says, I got a result. What does it mean? It kind of try to understand the result. Then, and then it repeats these steps again and again until we get a satisfactory answer, right? So this is a typical way which is React agent works. And I mean, in fact, this is how we solve any problem in real life also, right? So we first of all think and then we try something, right? And then we see the result. So if the result is okay, if not, then we again think some other approach. And then we again try that approach and then we again see the results. So we keep on going in a loop until we get good results, right? In real life also, we kind of use the same approach. So now let's see a real world example, how exactly for a query this React agent works. So let's say we have a query that is what is the population of Paris and the square root of that number, right? So what is the population of Paris and the square root of that number? Okay, this is the query. So now here, this is how it works. First of all, it thinks that I need the population of Paris first, right? And then it acts. It acts using a web search tool to get the population. Okay, then it observes that the population is nearly 2.1 million. Okay, and then it again thinks, now it thinks that now I'll calculate the square root of this particular number, 2.1 million, right? And then it again acts on this particular thought, right? It acts on that, and it acts on that using a tool which is a calculator tool, and then it finally returns the final answer, right? So now so what it did, it basically it combines multiple steps it combines multiple steps, switching between reasoning and acting, right? So it works like reason, act, and then observe, and then this keeps on going in a loop again and again until we get a satisfactory answer. So once we get satisfactory answer, then only we'll call it a final answer, right? So now there are several tools which can be used with React agents, right? So these tools, for example, I have put some tools here, right? Web search, calculator, file search, APIs, or database queries. And there are so many other tools, right? Any custom tool we can create as a function and we can use it, right? So now we'll quickly see a code and then we'll come back to the screenshots. Okay, so now we'll see how exactly we can create a React agent using a LangGraph workflow. Okay, so first of all we'll start off with importing chat Olama from LangChain Olama chat models, because we'll be using Olama for the model. Okay, and the model which we're using is Llama 3.1. Next, we are going to import all the necessary modules, right? Message state graph, human message, system message, duck, go search, right? And then tools condition, tool node, and so on. Then we'll create the tools. So here we have exactly three tools. which does unit conversion. The first tool is Celsius to Fahrenheit. It takes the temperature in Celsius and it converts it to Fahrenheit, right? And then it returns that particular value. The second tool is kilometer to miles. It takes the kilometer and converts it to miles. The third one is kilograms to pounds, which takes the input as kilograms and convert it to pounds. We have the fourth tool, which will do the web search for us, which is the DuckDuckGo tool. So, and now we'll put all these tools in a list here, and then we'll bind these tools with the LLM. Okay, so binding means the LLM will know when to use the tool exactly, right? And which tool to use in which scenario. So we'll bind these tools using bind tools for this particular method. Then we'll give a system instruction or system message. We'll say you are a helpful assistant tasked with using search and performing unit conversions on a set of inputs. Okay, then we'll create the reasoner or this particular method, which will be basically invoking the LLM, right, for any particular query. So it will take the input from the message state, and then it will invoke the query. Remember that we have already performed this binding of these tools with this particular LLM. So we are using this LLM with tools variable now. So this variable has the tools already binded, along with this LLM. Okay, now we'll create the workflow or the graph. So first of all, we'll create an object of the state graph class with message state, and then we'll start adding the nodes. So the first node is the reasoner. Okay, the second node is the tools, and here we are going to use a pre-built this tool node method to add this tools, okay, as a node. And then we'll add the edges. So we'll start off with the first edge, start to reasoner. Okay, and then we'll add the conditional edges. Okay, so here we will again use the pre-built tools condition to add the conditional edges here. Okay, and then we'll add the final edge, which is tools to reasoner tool, and then we'll finally compile this particular graph. Okay, so now if we try to visualize this, so the first node is a start and then reasoner, right? And we have an edge between this. And then we have a loop going on over here, right? The loop which we talked about in the theoretical part. So the LLM here decides whether to use a tool or not. So if not, then it responds itself and the workflow ends here. As in, if there is a generic question which does not need a tool call, then the LLM itself answers that particular question, and when the workflow ends here. But if the LLM finds that it needs a tool call or it needs to use a tool, then it sends that particular query to the tool call, right? And then we get the response from the tool, and then again it goes back to the LLM where it does the observing part, right, in our loop. Then it again, if the answer is correct, so it tries to observe the answer is correct or not. If not, then again it sends to the tool, and then finally once we get a satisfactory answer, then it responds back the final answer. So this is a loop, this goes in a loop, right? So now we'll give the input here. So we use the this particular human message, right, from LangChain, and then we give what is the weight of Elon Musk in kilograms and pounds, right? So now let's see, once we invoke it, so how this flow exactly goes on here. So our question was, or human message was, what is the weight of Elon Musk in kilograms and pounds? So it performs tool calls, right? It calls the tool, that function basically, which we created above, kilograms to pounds, right? So this is the tool which we created, right, for kilograms to pounds. So it automatically decides, that which tool it needs to call. And then it goes to duck search, right? So it goes into that loop. So the LLM decides that it needs a tool call. Then it goes back to the LLM again for the observation. Um, right. So first of all, it calls kilogram to pounds tool. Then it calls duck search, DuckDuckGo search, and then finally it responds to the answer. So if we see the tool message, first of all, it's the kilograms to pound, this one, and then tool message, it searches DuckDuckGo search, and then it gets the weight of Elon Musk, right? And then it tries to call some other tools, but it says that this is not the correct tool for this. So finally we get the answer using the kilograms to pounds tool, correct? Now let's ask the next question. What is the distance between India and Russia in kilometers and miles? So once we invoke this, so the human message is, what is the distance between India and Russia in kilometers and miles? So first of all, it calls the tool kilometers to miles. Then again it calls DuckDuckGo search, and then again it calls kilometers to miles. So that loop is happening, and then it gives the final response finally, right? So on the go, it automatically decides that which all tools from the list of tools which we created will be required here, right? And then it keeps on going into that loop until it gets the correct answer, right? So this is basically React, right? And now if we look at this particular diagram, which we already saw, so this is the starting node, right? And then we have the reasoner. Here we have the LLM, right? So here we are using Olama. Here we have the LLM. Then it decides whether it needs to do a tool calling. If yes, then it goes here. It gets the response and it comes back into the loop. This loops keeps on happening, right? Until we get a satisfactory answer. But if it decides that it doesn't need a tool calling, it simply responses back for any generic question. Okay. So now let's go here. Let's see the message. We have already seen this, right? So it basically, we ask the question, what is the weight of Elon Musk? Then it goes for tool calls. So it first it calls duck search, then it calls kilograms to pounds, right? In the next one, we again ask what is the distance between, if I can just zoom in a little bit. So we ask the question, what is the distance between India and Russia? So first of all, it calls the DuckDuckGo search, and then it calls the kilometers to miles. So using DuckDuckGo search, it finds the distance between India and Russia, and then it does the conversion because we want the result in both kilometer and miles, right? So this is how this sequential loop thing goes on, right? Until we get the correct answer. So this was all about a React agent using LangGraph, right? So if you want to test this code or play around with this code, you can go to this GitHub repository. I'll be putting this repository in the comment box in this video, and you can just test this or try this code, tweak this code according to your need, do some changes here, experiment with this. And just let me know in the comment box if you find this useful in your own project, right? So this was all for this particular video. So I'll be continuing with this playlist. I'll be covering various aspects of LangGraph, various agentic patterns which you can make using LangGraph, various concepts in LangGraph, and various projects also using LangGraph. I'll be covering here in this playlist. So subscribe this channel if you like the content. Like this video and share this video with your friends so that maximum people can benefit from this video. This is all for this video. I'll be back soon with next video. Till then, thank you. Thank you for watching this video.